Good morning to one and all. My name is Krishna Mohan. I am working as an assistant professor in Computer Science Department, Allied Branch AIML. So today's topic is digital computers. We are going to discuss computer system and architecture. In that we are going to see the topic digital computers. So initially we'll try to see what is a digital computer and what are the topics we are going to cover in digital computer. Once after completing the topics and units, then we'll start what is the basic digital computer definition. Then we'll go to the definition. After that, we'll see what is the architecture, what are the components of the digital computer. Then we'll see what are the features and what are the benefits and applications we are going to get once if we use a digital computer. Right? First, so what are the course outcomes? What are the course outcomes once if we go for a digital computer? So understand the logic gates and binary codes. Initially, we will try to see what are the binary codes and what are the logic gates defined for that. And design the sequential and combinational circuits. How to design the sequential and combinational circuits. After that, we'll try to get the differences between sequential circuits and combinational circuits. Then we'll go and understand the computer arithmetic and addressing modes. So what are the arithmetic calculations we are going to see for a digital computer? So it is like the addition, the subtractions, and then after that we'll try to see what are the logics and what are the shift operations we are going to see on the digital computer. Then we'll try to see and understand the apply concepts of memory units. So what are the different types of memory units we are going to see and how these memory units are going to work, that we are going to see under the third or the fourth part of our outcomes. Next, finally, we'll try to see and understand the concepts of I/O. What are the concepts of I/O? Input-output components, and how these input-output components are working and what way we are going to process the data in this particular input and output components, we'll try to see in the fifth outcome of the given subject CSA. Next. Now, we'll try to see what are the units and each unit what it is going to carry and what topics we are going to discuss majorly in all the unit 5, 1, 2, 3, 4, 5 of the computer system and architecture. Unit 1, we'll try to see what is a digital logic circuit. What is a digital logic circuit and what are the digital logic circuit components and what are the digital logic circuits. After that, we'll try to see the designing of flip-flops and what are the flip-flops. So what is a flip-flop and how to design a flip-flop, we try to see in unit 1. Next, coming to unit 2, we'll try to see what is digital components like decoders, multiplexers, the registers, binary counters. After that, we'll go and see the data representation, that is data types. How many data types are there? Is there any type of language which we use for the data representation? And after that, we'll try to see the fixed point representation and floating point representation. So these two plays a very important role in data representation, that is fixed point representation and floating point representation. Coming to the unit 3, we try to see what is register transfer and micro operations. Register transfer, how to transfer the data between the registers and how the data is stored in the registers and how the data is stored in the registers once if you are trying to increment the data in the register. So is there any another language for that? So we try to see RTL as the register transfer language to transfer the data between the registers. And after that, once after storing the data on the registers, we try to do some manipulations or operations. So what type of operations the data is performed on the register? Suppose if I take a register R1 and if I take a register R2, how the data is performed, how the data is operated on these two registers. So initially we try to store the data, we try to give some address to the data, and once if the address and data is given onto the register, immediately we try to do some operation on that. That type of operation may be an arithmetic operation or a shift operation or a logical operation. So all these type of operations which are related to arithmetic, logic and shift, we are going to see in this particular unit. Next, coming to unit 4, we are going to see basic processing units. So how the basic processing units and what are the types of basic processing units that we're going to see in the unit 4. So we try to see what is a hardware implementation and what is a software implementation. So coming to this, first initially we try to see what are the components required for basic unit, that is hardwired control unit and microprogrammed control unit. These two play a very important role in processing of data. So when I go with the hardwired control unit, what components are going to be used here and how the data is processed. Once if that is done, immediately we'll go to microprogrammed control. In the microprogrammed control, the data is processed, and once if the data is processed, immediately the data will be in the form of the instructions only. But coming to the hardware control unit, all the hardware components are interacted with one another and the instruction is going to get processed. So among these two, which is the best one? And once if I start the processing of the data, how the data is processed, that we are going to see in unit 4. Coming to unit 5, we will see what is input and output organization. Suppose if I have a digital computer, so what are the input components required and how the input component is processing the data. Once if the input component is processing the data, immediately the data should be processed to or transferred to the output component. Once if the output component takes the data, how it should be displayed and how it should be executed to the output component. So the output component may be a monitor, the output component may be a printer, or the output component may be an LCD projector. Whatever components we are going to use, that is going to be displayed on the output monitor. So these input components and output components are organized in a digital computer. So this type of organization we are going to see in the input-output organization. Further, we use what is a direct memory access and what are the vectors, what are the processing vectors. We are going to implement them in the input-output organization. So all these 5 units comprises different types of or some 5 components of a digital computer. So if we take initially unit 1, it is a basic or the introduction part. Coming to the unit 2, we go for component 2, unit 3, component 3, unit 4, component 4, and unit 5, component 5. So all these 5 components comprises a digital computer. So in depth, we will try to study what each and every unit is going to do for us. Right. Now, we'll try to see what is the introduction. So how the digital computer is going to process the data, in what way it is processing the data, that we will see as a definition, and after that we'll go and see what are the features for a digital computer. Initially, if you see, a digital computer processes the data in a binary format. A digital computer processes the data in a binary format. So the binary format may be 1 and 0. See, if you see here, the binary format may be 1 and 0 because the computer doesn't understand whatever language we are going to give. Suppose if I give the data or the instruction in the form of C or some C++ language or whatever type of language we are using, that cannot be understood by the compiler to process. So what we do is we try to give that language or the processing of data in the form of input component. Once if the data is internally processed, that processing of data or in the CPU, the data is processed in the form of 1s and 0s. So the performing of data will be in different ways. Suppose if I give 1s and 0s, what type of operations to be performed? The type of operations to be performed are arithmetic, logical, and they are going to be in physical and shift units also. So I can perform arithmetic operations, I can perform logical operations, and I can perform the shift operations also, where these are generally used in our homes, offices, industries, and some other organizations. So all these are commonly used in each and every type of organization. As in our home we can use in the organizations, and we can use in the industries also. Next, we'll try to see what are the features of a digital computer. Initially, we see what the digital computer works and how it is going to process. Now we try to see what are the features of a digital computer or the characteristics of a digital computer. Initially, if you see, it is speed of the processing will be increased. If you try to process the data in a digital computer, the speed of the processing will be increased, and then the accuracy will be high, and it is versatile. The accuracy will be more. Whenever we are trying to execute an instruction by using a digital computer, immediately we can say the processing speed is very high for that particular thing, or the accuracy also will be more. Immediately we will try to see the accuracy, the storage speed, and the automation of the processing of the data. Next, now we'll try to see what are the basic components required for a digital computer. The basic components required for a digital computer are input unit, output unit. Once after the input unit and output unit are processed, then we have to go for the central processing unit, where we call it as the heart of a digital computer. And how this particular CPU is organized. The CPU is organized into three components. One, we will call it as a memory unit. Then we'll go it for arithmetic logic unit. After that, we try to see arithmetic logic unit. So first component, we are going to make it as input unit. Next, we try to see what is a output unit. So once if we try to categorize the CPU is going to be considered as an arithmetic logic unit, control unit, and memory unit. CPU categorization is very important, where the CPU plays a very important role in the execution of the instructions. Once if the instruction has to be executed, we have to process the data in the CPU only. So CPU take care of all these instructions, process the data one by one, and then it transfers the data to the monitor or to the output unit. Now we try to see how these particular components, all these 5 components, try to combine together and give the instruction execution and the result for the user. So for this, we are trying to see here a basic architecture, where this architecture combinedly uses all the 3 components in a CPU. And initially, if you see here, we will try to go for an input unit, where this input unit is going to give the processing of the data, what data has to be processed. Immediately, once if the processing of the data is completed, the data is transferred to the output unit. Now, we start with the input unit component, how the data is taken into the consideration. Suppose if I say it as an input component, the input component initially will make it as a keyboard. In general, whatever input components we are going to process, that input components may be in the form of keyboard. The instructions are processed, or the instructions are given in the keyboard, where the instructions transfers from keyboard to the CPU. It carries the instructions to the CPU. Once if the instructions are carried to the CPU handles these instructions, and initially it handles all the instructions or transfers the instructions to the memory unit. It stores the data. Whatever data we got from the input unit, first it tries to store the data into the memory unit, or it makes a copy in the memory unit. Once if the data is made a copy in the memory unit, the data first initially it starts going from the memory unit to the ALU. Without making a copy in the reach of the memory unit, it doesn't transfer the data to the ALU. So who is trying to take care of all these processing of data from one component to another component? If you see, control unit plays a very important role among all these 5 components. Why? Because control unit will try to transfer the data from the input component to CPU, and it transfers the data, or it copies the data into the memory unit. Once if the data is copied into the memory unit, it tries to transfer that to the ALU. See here, if you say the control unit is going to play a very important role among all the components. No doubt all the components are going to play a very important role, but for the processing of data or the transfer of data from one component to another component, simply control unit is going to play an important role. Once if the data is transferred from memory unit to ALU, the ALU decides what instructions have been transferred from the input component. The ALU checks the instructions. The ALU verifies the instructions and says what type of instructions are going to be processed. Suppose if the instruction is an arithmetic instruction, or if the instruction is a logical instruction. So coming to the logical instructions or coming to the arithmetic instructions, it will categorize what type of operation to be applied. Suppose if I say it as an arithmetic instruction, it has to apply the addition operation or a subtraction operation or a multiplication or division operation. Among these four, it applies that on the particular instruction which has been transferred from the memory unit. Or else if the instruction is not to the category of arithmetic instruction, immediately it verifies and it decides it has to be a logical instruction. Suppose if it is a logical instruction, the instruction may be and, or, not, or different types of logical operations to be performed. It tries to see any one of these operations comes under the category and applies the logical operations. Or else if the instruction is coming under the category of shift operations. So how to shift the data to the left side or to the right side, and or if the data has to be processed in between the left side of the operation and right side of the operation. Whatever left shift and right shift operations are there, those operations are going to be categorized under the shift operation. So arithmetic logic unit plays a very important role by categorizing all these instructions which are given by the input unit. Input unit gives the instruction. Immediately the instructions are categorized and it has been transferred to the memory unit. They try to play one copy. They try to place one copy in the memory unit and then transfer to the CPU. So ALU tries to execute all the instructions, whatever category it comes under. Once if the instruction of the execution is completed, immediately it transfers the control or it informs to the CU. It informs to the CU. So how the CU will try to categorize? CU will get the information from the ALU in the form of an electrical signal. The control unit will get a signal from the ALU in the form of an electrical signal. So if it tries to give some green signal from the ALU, it indicates that the processing of the instruction is completed. If the processing of the instruction is completed, immediately the CU will try to get hold of the result and transfers that to the monitor or the output unit, because ALU doesn't have a capacity to transfer the data to the output unit. So CU has to carry that. CU has to take care of all the instructions which are executed. It has to transfer the output to the monitor. So in that way, the complete basic unit of all the components of a digital computer works with one another and tries to process the data and give the instruction to the output in the form of a monitor or in the form of a printer or any other type of devices what we are using. So all five components plays a very important role. We cannot say that any one of this particular input unit, output unit or memory unit or CPU, if any one of the component is not there among these, each plays a very important role. So we cannot take it as an option that we cannot work out with input or we cannot work out with output. All the components should be there when we are trying to process an instruction in a digital computer. Right? So once after the discussion of these particular components or particular input, output and CPU components are over, immediately we try to see what are the gates, what are the logic gates. Right? If these logic gates play a very important role while we are executing the instructions. The basic component of the instructions are done only with the logic gates or with the arithmetic logic units or with the shift units. So without these instructions or without these gates, we cannot move forward for the execution of the instructions. Right. Now we try to see what is a logic gate and what are the uses of this particular logic gate while you are executing the instructions. Right. Binary information is represented in digital computer using electrical signals. Binary information. Suppose if I say a particular digital component handles binary information. So how this particular binary information can be represented? For us, it will be in the form of ones and zeros, because we can see only ones and zeros. But internally, the representation for this digital computer will be in the form of electrical signals. So the signal may be green or sometimes the signal may be red. We can say it as on and off. These signals can be represented by voltage to specify one of the two possible ways. One of the two possible ways means we can say 1 or 0, or we can say it as on and off. Right. The two states represent the binary variable that can be equal to 1 and 0. The two states, whatever the states we are representing to that particular instruction. Suppose if I say the instruction has been executed, or the instruction has been processed, or the instruction has given some result for us. If the result has been displayed or the result has been processed, then I can say that the state representation will be 1. Suppose if the instruction gets failed, or the instruction whatever I am going to give through the input is not reached to the other component, that is to the memory unit or to the ALU or to the control unit, then I can say that the instruction has been failed. Directly we cannot say it as failed, we can say it as 0. Means if I telling it as 0, it is failed, or 1 if I say it has been passed or it has been success. Right. So gates are blocks. The hardware that produce signal in the form of binary when the input output is required in the form of satisfied conditions. All these things, whatever we are going to discuss in the logic gates, should be a part of the instruction what we are going to give, and these instructions will try to use or will try to execute the processing of the instructions in the form of logic gates. So if I come to the concept of gates, we will try to categorize the gates into 3 categories. So gates can be categorized into 3 types or 3 formats. The first one we'll call it as basic or fundamental gates. The first gate is categorized as basic or fundamental gates. So that the basic and fundamental gates comes under AND or NOT gates. AND gate, OR gate and NOT gate. So these 3 if you are going to consider, we can consider them as basic or fundamental gates. Next, coming to universal gates, we can tell them as NAND or NOT. NAND gate or NOT gate. Exactly, these are contrast to AND and OR. If I say it as universal gate, which comes under NAND or NOR, these two are contrast to AND gate and OR gate. So we try to consider the second gate as the universal gate. The third one is exclusive gate. Third one is exclusive gate, where we categorize this exclusive gate as XOR and XNOR. XOR and XNOR. So for these 3 types, we used to construct a truth table. In the truth table, we try to give what are the possibilities, 1s and 0s, 0s and 1s, and once if the 1s and 0s are transferred in the form of X and Y, then we'll get an output for each and every table. These tables are considered as the outputs of each and every logic gate what we are going to define. So first we try to go with the construction of the logic gates with basic gates, that is AND, OR and NOT. Next we will try to see what are the universal gates, that is NAND and NOR. And after that we will try to see what is an exclusive gates. What are the exclusive gates, that is XOR and XNOR. So these 3 types of logic gates are going to be constructed with some truth table, and with the truth table we are going to represent that for a symbolic formats also. We try to represent in the form of symbol, and also we try to represent in the form of truth table. Whichever is possible, we will try to represent and will represent them. Right. So we start with the basic gate, that is AND gate. So how the AND gate is written and how the AND gate is represented. In this type of gate, the output is high only when all the inputs are high. The output will be high when all the inputs are high. Means whenever I am trying to take the 2 inputs, as 1 and 1, the output of that particular 2 gates will be 1. Other than that, whatever combinations I am going to give will be low. Low in the sense it is 0. Right? Whenever we try to go for an AND gate, the AND gate representation will be, in this type of gate, output is high only when all the inputs are high. The output will be high when all the inputs are high, means the inputs should be 1 and 1, where I can say the output is 1. Other than that, the all other combinations, that is 1s and 0s and 0s and 1s, will be considered as zeros, or we can tell them as low. Right. Next, if we go to the OR gate, In this type of gate, if any input signal is high, then the output will be any one signal is high. Suppose if I say 1 0 or if I say 0 1, whenever I am going to get the input as 1 among the both, if I give 1 0 0 1 and 1 1, for these three combinations I am going to get high. High means I am going to get 1. Other than that, whatever combinations I am going to give will be low or 0. That is particularly for AND gate. Next, finally, if we go to NOT gate, after going to AND and OR, if I go to the NOT gate, this type of gate is also known as inverter. This type of gate is also called as inverter. Means the inverter means in this type of gate that contains only the inputs, not only one output. It contains only one input and one output. Means if I give 1 as an input, I will get the output as 0. Means if I give the input as high, I will get the output as low. Or if I give the input as low, I will get the output as 0. Inverter means whatever we are going to give as an input, that will be in the contrast. So like that, we are going to construct the basic and fundamental gates by using AND gate, OR gate and NAND gate. Right? Next we'll try to see how to construct the universal gates. So how to construct the universal gates, where I can say the universal gates are NAND and NOR. That is contrast of the AND gate what we have constructed in the basic gate, and NOR is also a gate which has been constructed as OR gate in the basic gates. We go with NAND and NOR gates known as universal gates because these are the contrasts for AND and OR. The output of NAND gate gives exactly opposite which is going to be constructed in AND gate. The output of NAND gate will be exactly the output of the opposite output of the AND gate. So whatever inputs we are going to give as an input in the AND gate, the outputs what we are going to get will be contrast for AND gate. The same thing if I construct an OR gate with some inputs, and if I am getting some output for that particular OR gate, here the NOR gate is going to be the contrast of that particular OR gate. So these two we are going to consider as basic or the universal gates. Next if we go to the exclusive gates, in the exclusive gate we have two types, that is XOR and XNOR. So how this XOR is constructed and how this XNOR is constructed. Suppose if I say XOR gate, this gate produces high output whenever two inputs are opposite level. Whenever the two inputs are at opposite level, we can say the output is high. Right? That is the contrast. The same thing if I go with XNOR gate, this gate is producing high output whenever the two inputs are at same level. Whenever the two inputs are at same level means, suppose if I give 0 and 0 or 1 and 1, means the two inputs what I am going to give as two lows or two highs, then the output can be high. So in this way, we are going to construct this exclusive gates, that is XOR and XNOR. And if I go with the universal gates, I will consider NAND gate and NOR gate. So NAND gate is exactly opposite to AND gate, and the NOR gate is exactly opposite to the OR gate. So basically, if I go to construct these gates, first thing we have to remember is the basic gates, that is AND, OR and NOT. If I am perfect with this AND, OR and NOT, I can easily construct that universal gate, and I can easily go for the construction of exclusive gates. So first we have to see and remember what things we are going to see in the basic and fundamental gates. So basing on these basic and fundamental gates, we can construct very easily the universal gates and exclusive gates. Right. Now we try to see what is a combinational circuit and what is a sequential circuit. Once if we define the combinational circuit and sequential circuit, we know the differences between them. How to construct this combinational circuit and how to construct the sequential circuit. See, it is a digital circuit whose output depends on the percent of the input, on the present input. Suppose if I am giving some inputs here, the present inputs, whatever I am going to give, the output is going to be generated. So if such type of inputs I am going to get, that is going to be considered as a combinational circuit. Sequential circuit, it is a digital circuit whose output depends on the present inputs as well as the previous as well as the previous. The combinational depends only on the present input what I am going to give, and the sequential depends on the present and the past. Suppose if I am getting some input as 1, 0 is equal to 0. I have to consider the output of that and the input what I am going to give right now. Suppose if I am going to give the input right now as low, so these two should be combined and then I have to go for the output. Sequential means previous consideration of the output and now the present input what I am going to give. These two should be combined and should be processed for the output. Next, it can be described by the output values. The combinational circuit can be described by the output values. It can be described the output values as the shortest values. Right. The same thing. It contains the memory elements. It contains no memory elements. Suppose if I go with the combinational circuit, it doesn't contain any type of memory elements. It contains at least one memory element. Suppose if the combinational circuit doesn't contain any memory element, this particular sequential circuit contain memory elements. So likewise, we'll try to see the differences between the combinational circuit and sequential circuit in detail with the circuit diagram of the combinational circuit and sequential circuit in the next class.